If you are a fan of our work, it is likely that you value rigor and humility in research and are open to changing your perspective based on new evidence. You may also appreciate seeing these same principles applied to important questions, such as, how can my donation have the greatest impact? The sponsor of this video, GiveWell, is dedicated to exactly that. GiveWell publishes all of their thoroughly researched reports, including details on past mistakes, all available for free. More information, including how you can have your donation matched, will be provided at the end of this video. An allergy can be compared to finding a spider in your bedroom and setting off a nuclear bomb. While spiders may be unsettling and are eliminated, so are your neighbors and your dog. You can be allergic to an astonishing variety of things: pollen, dust, insect stings, animal fur, any type of food, latex, and even your own sweat. One of the most surprising aspects of allergies is how rapidly they can develop, often suddenly and intensely. You can even develop new allergies. One moment you are enjoying a shellfish you've eaten countless times before, and the next you wake up in an ambulance. A shrimp could potentially be fatal. But what exactly are allergies? Why does the body react so dramatically to harmless substances? There is a fascinating and thought-provoking theory we want to share. Humans may have inadvertently created allergies by eliminating worms. This idea is both troubling and intriguing. For our ancestors, worm infections were an unfortunate fact of life. In a world where drinking water and human waste were often in close contact, certain species of worms found the perfect cycle for their existence. They entered the body through contaminated water, settled in for years, and later released their eggs or larvae back into the water through human waste. Until recently, from an evolutionary standpoint, humans had to cope with frequent or even chronic worm infestations, which led to various unpleasant health effects. As a result, the immune system had to devise strategies to fight off these parasites. But how could the body do that? From a cellular perspective, worms are massive, city-sized threats stretching far beyond the horizon. Worse still, worms don't have a typical skin, but instead a flexible protective layer that can withstand even stomach acid. It takes a powerful response to damage them. Essentially, when a worm enters the body for the first time, immune cells detect their presence. These cells then travel to the lymph nodes and activate special antibody factories called B cells, which are detailed in this video. These B cells are instructed to fight parasites and begin producing a unique class of antibodies known as IgE. Tiny protein molecules with 2 pinches that attach to worms like magnets. IgE antibodies flood the body, essentially preparing a deadly assault in the form of mast cells, which are large swollen cells filled with histamine and other harmful chemicals. These mast cells pick up the IgE antibodies and cover themselves with them, turning into explosive devices like angry grenades without safety pins, ready to detonate. These mast cells lie in wait until a worm enters the body. When this happens, the situation escalates quickly. The mast cells, with their IgE markers, latch onto worm particles and explode, releasing their toxic chemicals all at once. In the process, some chemicals damage the worm, causing significant injury. Other chemicals trigger inflammation, ordering the blood vessels to release water to flush the parasites out. Additionally, the body produces mucus to cover the worms in a sticky substance. while chemicals like alarm signals rally white blood cells, known as eosinophils, to the site of the battle. These cells arrive in droves, making the inflammation worse while carrying highly toxic substances that they use to tear apart the worm's protective layer. The response doesn't end there. The basophils, a type of immune cell, ensure that the attack continues without slowing down, recruiting more cells to intensify the assault. Meanwhile, the immune chemicals cause smooth muscles to contract, pushing everything inside the body out. This results in symptoms like diarrhea in the intestines as the body tries to expel the parasite, or mucus and water flooding the respiratory system to expel the worm. If the reaction happens under the skin, the tissue becomes red, hot, and itchy as the immune system carries out its violent attack. But what does all this have to do with deadly shrimp? Parasitic worms don't enjoy being destroyed by the immune system, and over time they developed various chemicals to weaken the body's defense mechanisms. These chemicals made the immune system less aggressive, which could be harmful to survival, as the body needs to fend off numerous invaders daily. Our ancestors could not prevent regular worm infections, so as the worms adapted to humans, our bodies had to adapt in turn. One possible adaptation was to make the immune system more aggressive in order to combat other threats. Then, relatively recently in evolutionary terms, everything changed. We invented soap, sanitation, and most importantly, separated drinking water from human waste. This disrupted the life cycle of many parasitic worms, and those that remained were largely eradicated by modern medicine. While worms still affect over 2 billion people today, mostly in undeveloped areas with poor sanitation, those of us who escaped this fate now face an interesting dilemma. The immune system, having evolved to fight worms, is now left without a major enemy. It is possible that our immune system still operate as if worms are present, overcompensating by being overly aggressive, even in their absence. IgE, mast cells, basophils, and eosinophils, which evolved to combat worms, may now turn against other substances, such as shrimp. This explains why some people experience allergic reactions to shrimp. The immune system recognizes shrimp proteins, producing IgE antibodies that prime mast cells for action. These mast cells, now armed, wait for the next exposure to shrimp. When that happens, the body reacts as if it were fighting worms. The immune system's destructive forces target the body itself, causing swelling, hives, and potentially severe symptoms like difficulty breathing, nausea, cramps, or even anaphylactic shock, where the body's blood pressure drops to life-threatening levels. This violent reaction is what makes shrimp potentially deadly for some people. An immune defense system, which for millions of years was vital for survival, now targets harmless substances. We still don't understand why some people produce a lot of IgE antibodies and others don't, or why some allergies develop later in life or disappear over time. The exact cause of this phenomenon remains unclear, though factors like the lack of worms, less diverse microbiomes, and increased pollution may play a role. What is clear is that allergies and autoimmune diseases have been on the rise over the past century, especially in places where sanitation has improved and worm infections have decreased. Hopefully, we will find a solution to prevent allergies in the future. One thing is certain: we don't want to bring back worms. GiveWell is dedicated to helping donors make informed decisions about high-impact giving. For 17 years, they have been researching and identifying the most impactful philanthropic opportunities. Over 125,000 donors have used GiveWell to donate more than $2 billion, and evidence suggests these donations will save over 200,000 lives and improve the lives of millions more. All of GiveWell's research and recommendations are available on their website for free. If you are new to GiveWell and wish to donate, eligible donors can have their donations matched up to $100 before the end of the year or until matching funds run out. Donations are tax-deductible, and GiveWell takes no fees from the funds.